Okay, so we are going to do some reviewing for our third test in college trigonometry for spring 2016. So what we want to do first of all is it's real important that you memorize the ranges of the inverse trig functions, particularly these three. So if you have a inverse sine, the range is negative pi over 2 to pi over 2, including the endpoints, and that narrows you down to quadrant 1 and 4. Okay, you can only take an inverse sine of numbers between negative 1 and 1. Okay, then the inverse cosine has a range from 0 to pi, which puts you in quadrants 1 and 2. And then the inverse tangent has a range from negative pi over 2 to pi over 2, like the sine, except the endpoints are not included. So it's 1 and 4. Now, I'm not going to worry so much about the other three. Those are things we're not going to use quite as much. So I want to focus, make sure that you have these down right here. They're pretty similar. The inverse cosecant is like the sine, except you're not defined at 0. And then the secant, inverse secant generally is going to be sort of like the cosine, except it's not defined at pi over 2. And then the cotangent is totally different than the tangent. It ends up being 0 to pi like that. But mainly it's the first three that you want to know. So one thing that you want to kind of get formalized in your mind is this. So if you did an inverse sine, an inverse cosine, an inverse tangent, really any of the inverse trig functions of a positive number, that's going to put you in quadrant 1. Okay, so that's always going to be the case on all these trig functions. If you have a positive, you're going to be down in quadrant 1 like that. So you want to keep that in mind as we do this. I'm going to take a little line and kind of make this into a little bit of a table here that might help you a little bit. So again, if you have a inverse trig function of a positive, you're going to be here. And if you do an inverse trig function of a negative, you're going to be in these quadrants. Okay, so the way it works on an inverse sine, if you do an inverse sine of a negative, okay, you're going to give me a quadrant 4 answer, but you're going to give a negative angle. On an inverse cosine of a negative number, you're going to give a quadrant 2 answer, and it's going to be a positive angle. And on an inverse tangent of a negative, it's going to be just like the sine. You're in quadrant 4, but you must give a negative answer, okay, for the angle, because you got to fall within that range. So it's real important that you get all of that figured out. And if you're in quadrant 4 on one of these things, again, you got to give a negative answer in degrees or radians. Okay, so this problem number 1 is a typical kind of thing. You're asked to do the cosine of the inverse sine of negative 3/4. And no, you don't need the calculator to do this. So when you look inside, this right here tells you actually 3 things. Okay, first thing it tells you is it's going to tell you what quadrant you're in. It's also going to tell you, since the sine is defined to be y over r, it's going to tell you what y is. And it's going to tell you what r is. Okay, r is always positive, so that's 4. So that would force the y to be negative 3 then, like that. Okay, and then we can find x. See, ultimately we're finding a cosine. So if you're finding a cosine, you got to know x over r. We already have r, we just got to find x. Okay, now the range of an inverse sine is this. Okay, so if you're doing an inverse sine of a negative number, that means you're in quadrant 4. So that means that you are located in quadrant 4, which means x is positive. So all you got to do on this problem then is just use the Pythagorean relationship to find what x is that we're familiar with. So we say x squared plus negative 3 squared is equal to 4 squared. So that's going to be x squared plus 9 equals 16. That's x squared equals 16 minus 9. That's x squared equals 7, square root both sides. And then technically you have plus or minus square root of 7, but since we're in quadrant 4, that means that's going to be a positive square root of 7. So this type of a problem, ultimately it boils down to just figuring out what x, y, and r are. And you're always going to know what quadrant you're in based on this information. So again, if you were given inverse trig function, if that's positive, and regardless of what the trig function is, you're in quadrant 1. Okay? If this is negative, it depends. If it's the inverse sine, you're in 4. If it's inverse tangent, you're in 4. If that's inverse cosine of a negative, you're in 2. So that's based on your knowledge, basically, of how the quadrants and the ranges of the inverse trig functions work. So now what you're ultimately doing on this problem is you're doing the cosine of some angle. Now see, this part in yellow right here is really giving you some angle theta. So what you ultimately end up doing on this problem then is you do the cosine of that angle theta. We never have to find that angle, but we know that's x over r, so x is square root of 7. R is 4, so that means the answer to this problem is going to be square root of 7 over 4. Now you're expected to do problems like this without a calculator. Okay, so that's a pretty important kind of problem. You see that type of problem on the gateway exam also that we do in trigonometry. So really it's x, y, and r. Okay, when you study how to do that kind of problem, just think of step 1 is figure out 2 of the variables because you're going to know, and you're going to know the quadrant, and then it's just a matter of finding x, y, and r and knowing your definitions of your trig functions. Okay. All right, next thing we want to look at is one of the things we learned how to do is solving an equation for x. We learned how to do this primarily to help us learn how to do an inverse. So when we're solving something with trig functions in it for a variable x, like anything else when we solve an equation for x, we're trying to ultimately get this variable by itself. So you're going to end up with x equals some number. Well, the first thing that you want to do is you want to have this tangent isolated. So you just want that right there by itself on a side. So what you're going to do to start with is you're going to add 4 to both sides as your first step. So let's write down what we have. We're going to write y plus 4 is equal to 2 times the tangent of x minus 4. Okay, so we've got that. Now the next thing we got to do is we got to get rid of the 2. So I'm going to divide both sides of this equation by 2. So that's going to leave me with y plus 4 over 2 is equal to, that divides to 1, the tangent of x minus 4. Okay, so that's the first thing that you want to do is you want to isolate that trig function. Okay, now the next thing you're going to do is you're going to do the inverse tangent of both sides of this equation. So I'm going to take the inverse tangent of the left side. Okay, then I'm also going to take the inverse tangent of the right side. So let's do inverse tangent of the right side. Okay, so we're going to be doing inverse tangent of the tangent of x minus 4. And I'm going to use maybe brackets like that. Okay. All right, so now what we do is we just got a couple more steps to finish this up then. So what I'm going to do is the left side just comes down. There's really nothing we can do with that. Just leave that alone as inverse tangent of y plus 4 over 2. And then this thing, whenever you do the inverse tangent of a tangent, and you have a variable expression, that's just going to come out to be x minus 4. Okay, so what we end up having here is this will be x minus 4. And you can kind of think of this as undoing the operation of taking a tangent of both sides. That's what you just did. So now what we can do is add 4 to both sides, like this, and then we'll have a good valid answer to our problem. So we're going to end up having x equals 4 plus inverse tangent of y plus 4 over 2. So the strategy for doing this is always about the same. Isolate your trig function and then do the inverse trig of both sides. Like that, and then that'll get your variable solved. Okay, so that would be the official answer to that problem. You want to be able to take some type of an equation with a trig function in it and be able to solve that. It's really mostly a two-step process. Isolate the trig function and then take the inverse trig of both sides. Okay, then by doing that, then you should be able to end up with your argument, and then you can solve that for x. Okay, next thing I want to look at would be finding the exact value of some of the trig functions in radians. So I'm going to pause this just for a minute. Okay, so I wanted to pull up a unit circle. Now, when you're doing your test, you're not given a unit circle, but you can create one. I give a blank unit circle, and then you can create it, and then you can use this as you need to throughout the test. Okay, so what we're looking at on this one is the arc cosine of -1. So what this really means is your job is to find an angle theta such that the cosine of theta is equal to -1. Okay, so a couple things that are important. The very first thing that you have to pay attention on this is you only get one answer to these problems. If I'm asking you to do a inverse trig function of some number, you're going to get one answer. So you want to be sure you study that. A lot of times students will give two answers of these problems, and there isn't two answers, there's only one. And the reason for that is because of the range. So the range of an inverse cosine is 0 to pi. So your answer has to be in that range. Okay, so what we're going to do is we're going to look at, we know that on a unit circle, the cosine is the x value. So what we do is we just look on the unit circle and we try to figure out where the x value is -1. And that's obviously going to be at pi. I want you to give the answer in radians. So that means the answer of this problem is going to be equal to pi. Okay, and see, you fall within that range. Pi is obviously at the end of that interval, so the answer is pi. Only one answer of the problem, and it's basically interpretation of the unit circle. Okay, now if we look at the next one, the inverse sine, all right, what you want to do on this primarily is you want to look at this number, and you want to pay attention to the range. So the range of a inverse sine is going to fall from -pi/2 to pi/2. So it's really going to fall within quadrant 4 or quadrant 1. Okay, so like we talked about, since this is a negative value, there's actually two places on a unit circle where y is -1/2, but those answers are not valid because they're not within range. So you cannot give me two answers, like I said. You also can't give me an answer that's out of range. So the most common wrong answer I get from students is 11 pi/6. That's wrong because it's bigger than pi/2. It falls outside of that range. So what you have to do is you have to look at reference angle. Okay, since you're doing an inverse sine of a negative, that puts you in quadrant 4 because of the range, but then you have to give a negative angle. Okay, so what you would do is you would give -30 degrees. That's a 30-degree reference angle, and it has to be negative if it's going to fall within this range. Then you can multiply that by pi/180 if you want to and convert that, so you would get -pi/6. So that's the answer of the problem. It's the only answer of the problem. So if you do an inverse sine of a negative number, you've got to be in quadrant 4, but you have to give a negative angle. So study that real hard, because it's not hard to do with the unit circle, but you got to be able to interpret that correctly. Okay, now if I'm going to go to the next one, I'm going to just sort of slide my unit circle down here just a little bit here, and so we can interpret that on this problem for the tangent. Okay, so as we go through this, what we're looking for again is we have an inverse tangent of 1. There's two things you got to look at. First of all, the range of an inverse tangent is going to be kind of like the sine, -pi/2 to pi/2, although it does not include the endpoints. So it means in this problem you're either going to give a positive answer from there to there, or you're going to get a negative answer from there to there. Okay, so you just pay attention to this. You don't pay attention to anything going on over here because that's outside of this range right here. All right, so the next thing is a tangent is y over x. So you're trying to figure out where y over x is equal to 1. Okay, and that is going to occur in only one place, and that's going to occur at this point right here, because if you did y square root of 2 divided by x square root of 2 over 2, you're going to get 1. So that's going to correspond to that answer, pi over 4. Okay, so that's how you look at a tangent, is you figure out where y over x is equal to that value right there then. Y over x is equal to 1. Okay, so that's how that would go. Now, so what you want to study on each one of these things, these type of problems, if I'm asking you to do a inverse trig function, one thing that's important is that you only give me one answer. Okay, one answer. Now, there are times when it's undefined, but in this case, there's never more than one answer. Okay, and then be sure that you pay attention to the range of answers. Your answer has got to be in the range or it's not correct. Okay, next thing we're going to do is review how to do an inverse. And inverses work like this. There's kind of a strategy you go through. First thing I'm going to do is I'm going to write down, instead of f of x, I'm going to replace f of x with y and just say y is equal to 3 plus the tangent of pi x. Okay, and when you do an inverse, these are the basic steps that you're going to do. You're going to start by switching the variables. And that just means you have x and y, they get interchanged. Okay, so I'm going to take the y, and that's going to change into x. Then I'm going to take the x, and that's going to change into y. So you do that. Second thing you do is you solve this equation for y. And a general thing that you want to do when you're solving for y is you want to isolate the trig function. Okay, so that's how I'm going to start this then. So I'm going to start by subtracting 3 from both sides. So you can do that like that if you want to. So you're going to get x minus 3 is equal to tangent of pi y. And then what you're going to do is do the inverse trig function of both sides. Okay, so we want to go ahead now and do the inverse tangent of both sides. Right, that, and then we're going to solve this equation for y. So you want to kind of carefully write all these steps out so that you don't make any mistakes in doing that then. Okay, so I've got the inverse tangent of the tangent of pi y like that. All right, so what we have is the left side is now completed. We have inverse tangent of x minus 3. If you take the inverse tangent of the tangent, then it just becomes the argument, whatever that is. So that's going to be pi y. And then you can divide both sides by pi if you want to, or you can multiply both sides by 1 over pi, which is kind of the way I prefer to have that written, is like that. All right, so your answer then is going to be written as f inverse of x is equal to this expression right here. So I'm just going to write that as 1 over pi times the inverse tangent of x minus 3. All right, so we got that. Now the next thing we're going to look at is the domain and range, and kind of get the handle of that. So one thing that you're given in this problem is you're given the domain. Okay, this is the domain of f of x, and I have to give that to you in order to make this a one-to-one function. So we're going to go ahead and write down the domain of this function is going to be negative 1/2 to 1/2, and I'm going to write that in interval notation like that. And I'm using parentheses because if you notice on there they have less than. We don't have less than or equal to, so we have that. All right, now the next thing is we have to figure out the range. Now the function I gave you was 3 plus tangent of pi x. Okay, so all we really have to know on this problem is, okay, what is the range of this? Well, a tangent has a range that's going infinitely low to infinitely high, so that range is going to be negative infinity to infinity, like that then. Okay, so we've got what the domain and range is. See, I'm always going to give you the domain of that because I have to make it a one-to-one function. You have to figure this one out. And there's other things that you could show up with. What if I gave you y equals 3 sine of pi x? Well, since you have an amplitude of 3, then the range would be negative 3 to 3. So you can figure out the range by your knowledge of graphing. Okay, now what happens is the domain of the function becomes the range of the inverse. So that thing comes down there because we flip variables, and then the range of the function becomes the domain of the inverse. Okay, so the domain of the inverse would be negative infinity to infinity, like that. Okay, and what happens, one of the things we learned about is an inverse tangent kind of does something like that. So it's going to go infinitely left, infinitely right, like that. So basically what you do is figure these two things out, and then you copy them. Okay, domain of function changes into the range of the inverse. Range of the function turns into the domain. So that's how you figure that out. Okay, moving on to the next page, we're going to now get into the equation solving. So on our equation solving, one of the things you want to do, there's different things. This is looking like a straightforward factoring problem. So you want to be able to factor efficiently on this. So we got one trig function set equals 0. This kind of is a quadratic type of equation. So what we're going to do is we're going to factor this. So the first term is this term. So the only possibilities are 2 cosine x and cosine x. Okay, for this last term here, the only possibilities are 1 times 1. Okay, now you want to make sure you get these signs figured out. So that is cosine x. This is 2 cosine x. Write down what you're trying to get, which is positive cosine x. So the way to make 2 and 1 to add up to a positive is have a plus there and a minus there. Okay, so we're going to have a plus there and a minus there. So one thing is you got to be very effective with your factoring. And if you factor something, make sure that it's right. I mean, don't even waste your time. Multiply it out. You know how to multiply fine, I think, and just multiply it out and make sure it's right. Okay, now what we're going to do is, since we got this thing factored efficiently, and we know that it's right, we're going to set each factor equal to 0. So we're going to do 2 cosine x minus 1 equals 0. And we're going to solve that equation. We're solving this on an interval from 0 to 2 pi. Then I have cosine of x plus 1 equals 0, like that. Okay, so what we're going to do now is we've got 2 cosine x equals 1. I can add 1 to both sides. Then I can divide by 2. So I'm going to look at cosine of x equals 1/2 and just kind of look that up on a unit circle. Okay, and then same thing here. I can do this, so I get cosine of x equals -1. So what we're going to look at is we're going to look at this, and we're going to look at this, and we're going to look at this basically on a unit circle, and see kind of what we have going on here. So I'm going to take my unit circle that I have here and just copy that and bring it down and paste it here. So you can use your unit circle that you create on the test, and it'll speed you up a little bit if you just refer to unit circle. So be sure that you know how to do that. Okay, so what I'm going to do on this then is let's figure out where the cosine is equal to 1/2. Well, the cosine is the x value. So you've got an x value of 1/2 in two places. You've got there and you got there. Now you're supposed to write your answer within radians from there to there. So those would be two answers. One answer is going to be pi over 3. Another answer is going to be 5 pi over 3. And then the cosine is equal to -1 at pi. So your answers are going to be pi over 3. That's where the cosine's 1/2. pi is where the cosine's -1, and 5 pi over 3 is going to be where the cosine's 1/2. So the final answer of the problem, just write it in a set notation, pi over 3, pi, 5 pi over 3 like that. So that should be your final answer to that problem. Okay, so that's how that goes. There's factoring. That's kind of a straightforward factoring problem, which you want to know how to do. And it's straightforward interpretation of the unit circle. And you're finding all of the places where the cosine's 1/2, there's 2 places, and all the places where the cosine's -1, there's 1 place in the interval 0 to 2 pi. Okay, next problem. This one requires an identity, so that's another thing I want to make sure that you know how to do. So I'm going to start this problem by doing a distributive property on the right side. So that's going to be 3 minus 3 cosine x. And what you're going to find on this one is, since you see this square, that pretty well tells you that you're probably going to have to do factoring. The problem is, you're going to have trouble factoring this because there's 2 different trig functions. So what you're going to do is, this clues you to this identity. We have sine squared x plus cosine squared x equals 1. I would like to replace the sine with a cosine so that I have nothing but cosines. So I'm going to just move that to this side, so I get sine squared x is equal to 1 minus cosine squared x, like that. So the substitution I'm going to do then is I'm going to replace the sine squared with what it's equal to. Okay? So now if I bring all this down, I'm going to have 2 replace the sine squared of x with 1 minus cosine squared of x. And then we got the right side as it is. Now what we've accomplished is we've got the same trig function in here. So now we need to probably just multiply out, get in standard form, and try to factor. So this is going to be 2 minus 2 cosine squared x equals 3 minus 3 cosine x. Now I'm going to get one side equal to 0. Now my thought on this is I always like the squared term to have a positive in front. So what I'm going to do is I'm going to move this to this side, and I'm also going to move the 2 to that side. Okay, so what I'm going to have is 0 equals, and I'm just going to write the 2 cosine squared x here. Okay, then I've got the minus 2, that moves over. Then I've got these things that are going to stay, plus 3 minus 3 cosine x. And you got to be careful with doing this, because if you don't do this right, your factoring may not work. So we're going to have 0 equals 2 cosine squared x minus 3 cosine x plus 1. Okay, then that's going to be what we're going to attempt to factor. So you have to use an identity to get anywhere in this problem then, see. Okay? All right, so I'm going to go ahead next, and I'm going to go ahead and factor this now. Okay, so I'll go ahead and do this here. I'm going to draw 2 parentheses. And the first term is 2 cosine squared x. So all that could be is 2 cosine x and cosine x. And then my last term is a 1. So all that can be is a 1 and 1. And then try to get your sines to add up to this middle term. And you can do this in your head if you want to, or do this visual. That often helps. So that is 1 cosine x. When you multiply these 2 things, that is 2 cosine x. And you want the 1 and 2 to add up to negative 3 cosine x. And the way to make that happen is 2 minus signs. Okay, like that. So what you're going to do is, now that we have that factored, is we're going to take this factor, 2 cosine x minus 1 equals 0. And we're going to go to the unit circle and solve that. Then we're going to take this factor, which is cosine of x minus 1 equals 0, and we're going to look at the unit circle and interpret what that is then. Okay, so this one you can just kind of rearrange in your head. You're going to have 2 cosine x equals 1. Then you can divide by 2. So you get cosine of x equals 1/2. So we're going to look that up on a unit circle, see where that happens. And then the next one, we can move the 1, add 1 to both sides, so we get cosine of x equals 1. And then we're going to interpret that one also on the unit circle. Okay, so let me pull up unit circle. And we'll finish up the problem from here then. Okay. So just looking at the unit circle that you would create, again, we're looking at the solution on this problem. They want you to solve it from 0 to 360 this time. So that implies that they want the answers in degrees this time. Okay, so pay attention to that. Okay, so here's what you'd do. You would look at where is the cosine 1/2. That would be where the x values are 1/2. So there's two places that's going to happen. One place is going to be at 60 degrees. The other place is going to be at 300 degrees. So we've got that as 60 degrees and 300 degrees. Then we're going to look at where's the cosine 1. The unit circle has a x value of 1 at 0. So that would also give an answer of 0 degrees. So now the problem is solved, and we can write that in the answer blank. In degrees, we would have 0 degrees, 60 degrees, and 300 degrees as our final answer. Okay, so typically I kind of vary from how I want you to solve equations. I might want it on a interval in radians. I might want it on an interval in degrees. Okay, so you want to have your unit circle down very well so you can start the test by making a unit circle, and then it'll help you with a lot of the problems you do on this exam. Okay, so to finish this up, there's two more problems I want to look at, two other equations. And what I want to look at on this is, this one we're finding all solutions. When I say all solutions, that's usually when you have, pi k, k is an integer, for example, that type of thing. So the first thing that you got to do, this one is a multiple angle. It's got a period change on it. So what you do is you want to follow the technique of doing this very, very carefully. So we're going to say 2 sine of 4x minus square root of 3 equals 0. The first thing you're going to do is you want to isolate this trig function. So you want the sine of 4x to be all by itself. So we're going to do add square root of 3 to both sides. Okay, so that's going to give 2 times the sine of 4x is equal square root of 3. And then what we're going to do is divide both sides by 2. So we end up with the sine of 4x is equal to the square root of 3 over 2, like that. So that's how you want to start doing that. Now what you end up doing on this, and then the steps on this is kind of what we call a multiple angle equation, because there's a period change. There's 2x, 3x, 4x, something instead of just x. So what you want to do, again, is you want to isolate the trig function that you're solving. Then what you do is you do the inverse trig of both sides. So what I'm going to do next is I'm going to do the inverse sine of both sides of this equation. So I'm going to do the inverse sine of the sine of 4x. Okay, then I'm going to do the inverse sine of square root of 3 over 2. Okay, now what that's going to leave me is, you know that if you do the inverse sine of the sine, then the argument is what comes out of that. So you have 4x is equal to the inverse sine of the square root of 3 over 2, like that. Okay, then what you want to go through and do is you want to bring this over here, and then we're going to set up and kind of look at the unit circle. So let's write down 4x equals inverse sine of square root of 3 over 2. Okay, then I'm going to just bring up and paste a unit circle here real quick so we can use this to interpret the rest of the problem. Okay, so now what we want to do is you want to take this in two directions. So the first thing you want to do is look at, this thing right here. What this is saying is, where is the y value equal to square root of 3 over 2? And there's two places. So the square root of 3 over 2 for a y value occurs at this angle, pi over 3, and it also occurs at the angle 2 pi over 3. And in this problem, I think if you look at the directions, I want all solutions in radians. And if I want all solutions, that means I'm going to write a formula. So what I do is I do this. I say two things. I say 4x is equal to, and I say pi over 3, but then I have to say plus 2 pi k, or 2k pi, however you want to do that, with k being an integer. Okay, because in general, every time you add 2 pi to that, you're going to have another lap around the circle and keep getting to the same place over and over again. Then you want to do 4x equals the second answer, which is 2 pi over 3 plus 2k pi, where k is an integer. Okay? And then we're going to solve this equation for x, so we can divide by 4. Instead of dividing by 4, to me it's a little better when you're doing this problem to just multiply both sides by 1/4. Okay, because that's going to cross that out. That's going to leave x. And then when you multiply this, that's going to be pi over 12. You have a period change, so that's what's happened. Then you're going to do the 1/4 times 2 pi, so that's going to be 2 pi k over 4, which reduces down, and then you can write that answer. So we just say x, we can say set of x, such that x is equal to pi over 12 plus, and see this is now k pi over 2, so we're just going to say k pi over 2, and that'll give us the first answer. When we do the same exact thing down here, we multiply both sides by 1/4. Okay, and when I do that, I'm going to end up having x is equal to, and then this would be 2 pi over 12, and then this would be 2k pi over 4, with k being an integer. And then what you can do is just reduce those fractions. So we have pi over 6, and then k pi over 2 like that. So our second answer is going to be x is equal to pi over 6 plus k pi over 2, with k being a integer, like that. Okay, then that will be the solution to the problem. Okay, now one thing that you want to notice on this is this. If you look at the original problem, okay, so if you have the sign of 4x, the period is 2 pi over 4, or that's equal to pi over 2. So notice that came up in our answer. So you're going to expect that to happen. So if you follow these directions real carefully, when the answer changed from pi over 3, you can kind of notice it changed from pi over 3 to pi over 12. That's figuring in the period change. Then it changed from 2 pi over 3 to pi over 6. Again, that's figuring in the period change like that. Okay? All right. So that'll take care of that. Let's do one more here. This is one that's got a tangent in it. Okay, so this one we're going to find all solutions. That means, again, we're going to have a formula, and then this time for a tangent. Okay, so the first thing on this one, we're going to do unit circle on this, is we're just going to isolate the tangent. So we're going to have tangent of x equals square root of 3. And we need to just look up the unit circle. So I'm going to slide down my trusty unit circle here, if I can. And we'll interpret hey, what in the world did I just do? I have no idea what I just did. Okay, come on, slide down, don't do, just all I want to do is slide. There we go. Be a good computer. There we go. All right, so now what we're going to do is just look at where y over x would be equal to this. Okay, so really on a tangent, we know that the tangent's y over x. So you got to figure out where this happens. One thing that I do a lot on these problems is instead of going to the unit circle, now you can go to the unit circle if you want to, you don't have to do what I'm doing here, is the basic thing is I know the tangent is positive in quadrants 1 and 3. So I'm going to draw a reference triangle, and y is going to be square root of 3, and x is going to be 1. So see, basically that is a 30, 60, 90 right triangle, so I know that's going to be 60 degrees. Okay, and if you look at 60 degrees, even if you look at the unit circle, notice on this y is square root of 3 over 2. So you got that. divided by 1/2. So if you do y over x, you have square root of 3 over 2 times 2 over 1. So you get square root of 3. So you'd have 60 degrees there. Okay, then if I did this quadrant, it'd still be the same thing. It would now just be negative root 3, negative 1, but it would still be a 60-degree reference angle. So that's going to end up being 180 plus 60, or 240 degrees. Okay, so 240 degrees is the other place where this happens. Now, one of the things you're going to notice on this is if you look at a tangent, what's kind of special about a tangent is these angles are already, if you look at it, they are already 180 degrees apart. That's why I'm trying to just draw this little thing there. That distance from there to there is 180 degrees. Okay, so if we write our answer, we're supposed to write a formula, so we could say set of x such that x is equal to 60, but the period, one thing you want to remember is the period of a tangent is 180 degrees. So you could say 180 degrees k, with k being an integer. Then you could say x is equal to 240 degrees plus 180 degrees k, with k being an integer. And the thing is, this is unnecessary, because if you notice on this, 60 and 240 are already 180 units apart. So 60 plus 180 is going to give you 240. So that means that's not necessary. So you just write the answer as set of x such that x is equal to 60 degrees plus 180 degrees k, with k being an integer. So tangents are kind of unique in that way, that the answers, if they're within quadrants, are always going to be 180 degrees apart, so you don't have to write both solutions like you did in the previous problem. Okay, well, that'll end us up on part 1 of this. Part 2 of this review has to do a lot with the triangle problems and things that you need to use your calculator on. But this is a great overview. These are the kinds of things that I want you to know how to do. Obviously, it's different problems, but these are the key concepts that you want to make sure that you know.